and back-end. So what we see, what we interact with is usually known as
The front end.
front end, right? So it can be very fancy, looks very professional, designed well, very easy to use, so friendly, beautiful. Sometimes in the back-end side, something else is happening. You never know what kind of mess is happening there. So how the connections actually are happening, how the traffic is controlled and monitored, how the server is receiving your request, how is it responding to you and possibly 100 other machines, right? And so on. So we will talk about back-end in general later in more details, but for now, this chapter focuses on front-end. Now you are actually having a privilege. Let me tell you what's happening here. So when we discuss here desktop GUI, when we discuss desktop graphical user interface, we simply look into front end and back end as a single platform. So only one language, which is Java, let's say, using its own framework, which is JavaFX, is all you need to build both. Yeah? When you move to web, it's different. So you will be coding front end and three languages. Then with the back end, you can move into 2 more languages. And these 5 need to work together to provide the full functionality. When it comes, let's say, to mobile, you have to work front end, let's say, as these are just example, okay? So front end can work, let's say, with XML if this is Android, and the back end could be either Java or Kotlin if this is Android. If this holds iOS, then you have C or Swift.
Yeah.
And you have also Flutter, like that uses Darts. So these are different languages, but again, they have to coordinate and work together, right?
I have a question.
Please.
So for front end and back end, they're completely different languages. How can we get them to interact with each other? Is there like a medium?
There is, okay. So we look into it as components. Remember when we discussed it in the previous course, component?
Yes.
So the component is what you can interact with, okay? And it depends on linkage a lot. So I have one file, let's say, that's written in HTML, okay? This file, it's compatible syntax-wise with CSS.
Oh.
But how it works, it's through a link, okay? So this link tells it, okay, you are connected to another file for the style rendering, okay? Another link to JavaScript file.
And can I ask what these links are exactly?
These are simple line of code, okay? So I can tell I have link, and this link is taken from, for example, a file that's called style.css. It's as simple as that.
And only specific languages are compatible with one another, and they were made so by the people who made the language.
Okay, that's very good. They are made compatible mostly because their framework is matching. Like, okay, you will take this later. Like, some languages were generated from another language. Okay, like when we look into the C family,
C++, C
you have
Sharp,
C,
Java.
C++. I mean, a lot of things,
Yeah.
right? We have C sharp. We have unsigned C, right? And they built Linux, if you know it, as an operating system.
Yes.
Yeah. Now Linux became the core. Linux is so powerful as an operating system, by the way. I mean, it's not very common that people use it, but trust me, good programmers.
I've been meaning to switch to Linux.
I mean, it's not easy, honestly.
Yeah, I
Like
saw.
you will feel a difference, but it is very, very, very powerful. And lots of things you can do with Linux that are not supported with Windows and Macintosh. It's crazy, actually. It's crazy. But anyways, so just to answer your question, some languages are either generated from other languages, or the compiler deals with the idea of keep on translating. So this can be from moving, let's say, from low level to high level. And it can work like in a very good manner, let's say with another language that's high level. And usually within the same layer, so high level languages can communicate with each other. Low level can communicate with each other. You will need additional tools to let a high level communicate with a low level, like translators.
Okay.
Okay?
And will we get to that in this course?
Operating system course.
Okay.
And which part? You're asking
I mean
about?
the translating and the...
Okay, you will take it in web. You will take it. No, web operating system mostly. These two courses. Yeah.
Thank you.
And also perhaps in embedded systems, because you will need to know how the translation also happen on low level, then communicate with the hardware side. Yes. But technicalities like theoretical concepts, a lot in operating system course. All right. Let me just remove that thing really quick so you can resume. Okay. So how things started. Java is known to be an object-oriented programming language, right? And it's very powerful when it comes, let's say, to data processing. We have different structures that we can deal with. Okay. So they started with something we know as AWT, standing for Abstract Windowing Toolkit. That was the start. So back to my time, actually, I used to study these two. Okay? Now you're here. And I can tell you, just coding wise, something that you can do, let's say, in 10 lines here, can be done here in 5 lines, can be done here possibly in 3 lines. So these are how these libraries were improved over time. So from AWT, they moved to Swing, and from Swing, they moved to JavaFX. And the reason behind this name was they wanted something more flexible. So they thought of Swing, actually. Like you can provide more features in terms of better graphics. You can render this, yeah? You can look into how data are visualized, so charts and other work. And JavaFX came in to really implement the flexible concept, so Java flexible, okay? And this was mostly providing the feature of implementing over desktop framework, or let's say over web. It's compatible with other languages like CSS, so we can style it if needed. And it was more secure, so it holds up all features from previous frameworks, but in more advanced way. And of course, it's compatible with too many operating systems like Windows, Linux, and Macintosh. So let's start classifying some of these applications first. We have desktop applications and internet applications. So when something works over the browser, it requires, let's say, internet. This is usually internet application. If it's working offline, like it's an icon, let's say, on your desktop, you press this icon and it opens for you. This is what we know as a desktop application. So let's get started with the first two libraries, AWT and Swing. So we will see the progress over time. So here we work mostly with 4 concepts: container, layout, component, and graphics. Exactly, what are these? So what is a container? Container, exactly. Think of it like a big container you put stuff in, right? So when I think of desktop application, usually I see a frame, yeah? Like this. So this frame could be looked in as container, right? How about layout? So the way I see you now, you're all seated in layouts. How's that?
Is it like the way the things are organized?
Hmm?
The way the things are organized?
Very good, nice. So can I tell, for example, this is grid paste, like rows and columns? Yeah, I can see 4 ladies in a row. Yeah, 2 ladies in a row, perhaps 2 ladies in a column, right? That's how I see you now. So layout defines how the items are actually designed in a structure. Okay? Then comes the component. What is the component? So what do we interact with? Buttons. Huh? Huh? Text. Thank you. What else? Images. Huh? Videos.
All individual elements.
All individual elements. Thank you. And this is simply, I would say, a simple example is a button, right? Now, can I see them in another way? Everything you see here is nothing but what? Huh? Yalla, +1, whoever will answer. And you're close. What? Everything I'm seeing here, container, component, layout, graphics, what are these?
Options.
No. It's part of you, of course, it's part of the graphical user interface, but what are they?
Symbols. Classes.
Close.
Interfaces.
Who said classes? You're very close. Very close.
Packages.
Packages. Projects.
Far away.
Objects.
Objects, thank you.
I said objects.
You said objects?
Yes.
I'm sorry, I didn't hear. Okay, then I'll have both names. +1 for both of you. So lean and? What? Your name?
اسمك اعطيها اسمك.
Layla. Layla, okay. I hope that the only Layla here?
Yeah, that's
okay. And Lean, your family name? Okay. Thank you. Yeah, everything you will see here is nothing but an object. That's why we introduce class as an object in the review.
Object of what class? Of which, object of which class?
We will talk now about this, okay? But in general, okay, let's have a look at the container first. I can classify containers only to be 5 types: frames, panels, applets, dialog, scroll pane. What are these? Any idea? Okay. Frame is what we see here. That's a frame. Make sense? A panel is when we see some of these components, they belong to one title, right? So we call this a panel. And this panel can tell you actually how they are arranged. So think of it like a layout, but it's not a layout. It has to be relevant content, okay? What about the applets? Any idea? Publishing on browser. So it is the same application, but instead of seeing it at a desktop, I published this as a web application. Dialog. Dialog are simply any alert, warning messages, right? Where do we see it? See this. What is that? It's a dialog. In my case here, this is warning dialog, right? So it gives me a message, and I have to respond to it. See, I cannot do anything. I can't even interact unless I respond to it. Yeah? So let's assume I'm clicking this card. Another type, let me show you. I should have removed this. Sorry. Okay. Now, do you see this one here? Do you see this message? Like, I'm securing this file so no one can edit, okay? So this file provides for me also a note that I need to enter a password, but it's also interactive. So I have to input something to it. Again, this is dialogue, but other type of dialogues, not just informative. Okay. And I have the scroll pane. Scroll pane, from what the name suggests, I have something within a defined width and height. Yeah? But if the content exceeds that size, I need to provide scroll that could be horizontal or vertical based on the need. Now let's see layouts. Okay, I start here with the grid. Do you recall anything seeing a grid?
The schedule.
You're close.
Array.
Arrays, 2D arrays, right? So this is row, column. And the nice part about the grid is you don't have to fill it all, by the way. I can just keep few of them empty if I want. Now box layout, you put things in one box. This box can be horizontal or vertical. So here in that case, this is a vertical box, right? If I decide to make them this way, then this part is horizontal. Nice. Now, how different is the horizontal layout from the flow layout? Any idea?
لا يمكن إذا كانوا horizontal لازم كلهم تحت بعض، أما بالتحت عادي لو اثنين بس ثلاثة فوق.
That's a very good point. Let me tell you here a good rule to keep in mind, okay? So with the box layout, we limit things to a single row or column. So if this was vertical, I limit this to a single single column, right? If this was horizontal, I limit it to one row. No matter what, no matter how big is the width, it has to be one row. So if I have two, for example, two buttons that say, for example, click here, okay? And if I decided to shrink the size of the width, this can be something similar. So it will rescale the two buttons widths based on the new space provided. That's in the box layout. In flow layout, it's different. Okay, so flow layout prioritize the content. It has to be visible. Okay? So if this is, let's say, showing here 5 buttons, it means that the content requires at least 2 rows to be displayed. Okay? If I decide to shrink it, so let's make this my interface. What do you expect? This? Let me make it a bit bigger. That's going to be the space.
It's gonna shrink though, to put them all inside.
Okay, how so? So it will keep 2 buttons, then this will move here, so 3 and 4 gets into the second row, then 5 will be pushed into third row. Okay, that's a very good point. Okay, think of this one like a table, okay? It's not shown clearly now, okay, but here, each cell could scale up to an entire pane or an entire layout. So I can list them if I want, okay? This is not the case. It's one type and that's it. You can still reuse multiple types in one interface. So here, every cell, I can design it in a different way, yeah? Here with the flow pane, we mostly talk about components. So how these components will be arranged, okay? But again, in practice, you can see that sometimes they look the same, yeah? That's a good point. Okay, now last one here is the border layout. And this is super clear. So you put things in one of 5 locations. Either top or bottom, or right or left or center. Okay? Good? Again, keep in mind that this could be a whole layout if I want. I can design it the way I want. Same for this, and so on. Now components, as we said, could be literally anything. So it could be a button, could be a radio button, could be a checkbox. What is the difference between these two?
Checkbox, you can check many of them.
Excellent.
Yes, there is only
Exactly.
one.
Multiple options versus one, at most. If I ask for a username, password, or let's say your, I don't know, your phone number, just anything that would require a single line of input. This is sometimes referred to as
Text box.
text box, or let's say text field. It has lots of names. Okay, sometimes they call it input field, and so on. Okay? Anyways, we'll see the exact names once we start the coding part. Here, now this is what? So you have, for example, to write a review on any product that you purchase. Usually they give you at least 2 to 3 lines, free ones, let's say, to enter something in. What do we call it? Text area, right? So text area. I can also look into images, videos, audios, and so on. Now graphics, what are these? Okay, good. So usually, images usually and all multimedia are classified to be components, usually. How about the graphics? Colors.
Shapes.
Text, fonts.
Again?
Fonts.
Fonts, okay.
Size. Animations or
Size.
special effects.
Animation, very good. That's nice, okay. So yes, I can look into shapes, different shapes, like how you build anything. It's usually the collection of points, right? Or collection of lines. Yeah, so I can look into a circle, a line, and any possible formation of dots and lines. Points and lines, not dots. Okay, that's an example showing you a sample from AWT, from Swing, from JavaFX. Just observe for a minute and tell me what clearly, like the differences that you see. Yes.
The way the button looks.
The way they are,
The way the button looks.
the way the button looks. Okay, so here we can say this
Can you
is
say the
sharp
font?
edge,
The distance.
a bit rounded, highly rounded.
Difference
Yes.
in font.
Font, very good. So I'm just gonna say angle for the first one. Font,
The margins.
margins, very good. I love the word.
The color.
The color, good.
الوضوح.
So which one you think is more modern, comparing all the 3? So that's how it went, okay? So towards JavaFX. Now this is not the limitation of JavaFX, let me tell you. So remember when we discussed the compatibility with other languages? Now this works the best with CSS. So I can control, as you mentioned, I can control fonts, backgrounds, margins or spaces. I can control colors, background colors, angles, everything. Every single property, you can have full control over it. So that makes JavaFX literally so powerful too. That's a sample, but again, not the best. You can come up with ways better designs. This is still in gray-like format. In general, okay, so here we can notice, for example, different size, different font style, right? I can see that some of these text turned into bold, maybe italic, underlined, whatever. What else? This background color turned into texture. The button was also styled. Okay, in JavaFX in general, you will see a lot of import statements. Okay, every component, every layout, every, what is it called? I mean, we will call this later in I think 1 or 2 slides. But in general, everything will require its own import statements. So how we start, we have our own class, and I think till that part you know it. Very common to what we did previously, right? Now the extra part is this one, right? Now that's an application of what? Inheritance, thank you. Yeah? So that's an application on inheritance. But again, I'm extending here a class that's built in already in Java. I call it application, capital A, pay attention. Now, with the import statement, I need to say, okay, I'm importing the JavaFX framework, application library, with a small a, yeah, dot, asterisk, and this asterisk indicates what?
Everything.
Everything, right? Including which class?
Application.
The application class, thank you. We prefer to go generic most of the time because it could be one library and you need, let's say, 2, 3 classes under which. So instead of just having a lengthy list of import statements, you can just use the dot star for efficiency. But in general, if that's all you need, then dot application capital A will work. So to start with JavaFX now, we still build on the previous concepts, but the way the syntax would be written, the way things would be named would be a bit different. So we will think of it like a theater. What do you see in a theater?
Seats.
Seats?
Screen.
Okay.
Stage. Props.
Okay, wait, hold on. Let me type. Come, tell me.
Background.
We see background, okay.
Special characters.
What?
Actors.
We see actors, okay. What else?
Props.
Props.
Stage.
We see stage, okay, good. What else? So what the actors are actually doing?
Acting.
Yeah, in what?
Moving.
Characters.
In scenes, right?
Oh.
They create scenes for you, yeah? Okay, what else?
Characters.
Costumes.
Okay, so I'll call this styling, designing.
Okay.
Okay, let's call it style for now. Okay.
Also, we have special effects on stage.
Special effects, like,
Lighting.
very good. Let's call this animation. What do you think? Okay, very good. Okay, I think we can move now. So in the previous AWT and Swing, we introduced 4 concepts. Container, right? We said layout. We said component. We said graphics. Yeah? Now in JavaFX, we said this is taken from theater logic. So we have stage, we have a scene, we have a pane, we have a node. Now if we are trying to map these 4 to these 4, can you tell? So stage is equivalent to which of them?
Container.
Container, excellent. How about the scene?
Layout.
Okay, scene doesn't have equivalence, okay? I'll talk about it in a while.
Pane is layout.
Pane is layout, very good.
And component is
Component is nodes, very good. Why do we call it node?
because it's like
Place
a
them all
single
together.
point in the
Where did you take this word before?
physics.
In physics, okay, how about data structure? Haven't seen it yet. So we have something we know as trees, okay? You will take this. So there is trees, okay? Like how you think of inheritance, let's say. Remember the hierarchy of object, or even in the exception tree, if you remember this one. So we had the throwable, we had exception, runtime error, and stuff like that. We call this tree. And the tree classes in that case was single node. The class was treated to be a node inside that tree. Same here. So every small component will be considered a node in your big tree. Okay? Now what is a scene? Let me show it to you in practice, then I will end it. So, now this is zoom, let's say. Okay? So do you see these controls on top? Do you see that gray area?
Mhm.
At this point, okay? So do you see that part?
Yeah.
Okay. We call this what?
Container?
Now this is the stage. Okay? Okay. How about this white space that fills up the whole thing? Uh-oh. Okay, never mind. Yeah, how about this white space, the internal one? Now this is what we call scene. Now there is a limitation of the scene. A scene can accept a maximum of one item inside it. Yeah? How many items do you see inside the scene here?
A lot. But it's,
How so?
the layout is just one. So,
No, not the layout. So the scene is one,
yeah.
but the layout, or what we call it here, pane, this is multiple ones,
Mhm.
right? So inside this scene, I can decide to fill it with a parent pane.
Yeah, that's what I mean. And then everything else is inside.
Exactly,
So
excellent.
technically there's only one in this.
Very good. Now inside the pane, I can have many nodes, buttons, text, images, doesn't matter, right? So here, these are simply the nodes. Yeah? The way they are arranged, this is what we refer to as pane, right? This white space.
Pane is the arrangement.
Pane is the arrangement, yes. The white space is what we refer to as scene. The big frame is simply the stage. Yes, done. How different is it from what we saw? The grid, the box, same concept, but again, it gets more efficient. So we will see different other types. The naming is different, the way they are implemented, coding wise, is also different. But concept and logic, same. Okay? So, any question on today's session? All good?
Yeah.
How do you see the first part?
Good.
You like it?
The-
That's great. Okay, so please prepare